Well, our first topic today is the power rule, and we're titling this power rule 1 because we're going to split it into two different videos. Normally, in the bridge, we'd spend a full day, a full 3 hours just on the power rule. It is such a big concept before we can move on with higher order calculus here. So what is the power rule? Well, it's just a simple way to find the slope. Okay, so remember, we're just finding the slope. Before I just tell you the rule on how to find the power rule, I want to give you a few quick examples. So let's see if you can guess the power rule before I even tell it to you. Let's say, y equals x to the third power. Its derivative, its slope, so I want to make a note for slope, we're going to call it y prime. Its derivative or slope is 3x squared. Okay, so just soak that in for a moment. Let me give you another example. If y equals x to the fourth, its derivative, so what's y prime, is 4x cubed. Do you see a pattern at all? I want you to think about it. Pause it, think about it. And I'll give you one more. If y equals x to the 101st power, its derivative is 101 x to the 100. Does anybody see a pattern? Do you think you can find it? This is the power rule taking place. If you've got it, that's great. Let me switch back and just really give you the formal definition in case you didn't copy or figure it out yourself here. So here's the rule, and this is what you want in your notebook, of course. If f of x equals x to the n, where n cannot be 0, so it can be any number, a fraction, a decimal, a whole number, a positive number, a negative number, just not 0, then its derivative is nx to the n minus 1. And what I want you to make note is that for the power rule to happen, it must be a variable raised to a constant. And again, you're going to hear that word constant a lot. A constant is just a number. So you've seen me do a couple different derivative notations now. When we use y, we call its derivative y prime sometimes. If we use f of x, we call its derivative f prime of x. Sometimes we call y, when we're talking about with respect to x, we'll say dy dx. The derivative, d for derivative, the derivative of y with respect to x. If I said g of p, g of p, its derivative would be g prime of p. So the function was g, so I'm deriving that function. P is the variable in it. So just different ways you'll see notation for the derivative. It just depended on what mathematician founded it in that time. All right, so let's practice some derivatives here with the power rule. So if f of x equals x squared, f prime of x, so according to the rule, when I take the derivative of x to the n, it becomes nx to the n minus 1. I'm literally taking this n, I'm bringing it down in front, and then I'm taking that n and I'm subtracting 1. So I'm going to take this 2, bring it down in front, and then I'm going to subtract 1. So this derivative would be 2x to the first, or just 2x. So the power rule says take the exponent, bring it down, and then subtract 1. Number 5, if I have x cubed, so g prime of x, so I want to derive both sides. If I see g of x, then the derivative of g becomes g prime of x. Power rule says take that exponent, bring it down, and then subtract 1. You don't have to put the minus 1. Hopefully you can do that in your head. If you need to put the minus 1, go ahead. But 3 minus 1 is 2. So 3x squared. Number 6, h of x equals 4x to the negative 100. All right, so we're getting a little fancier here. So I'm still going to take that exponent, bring it down in front. So I'm going to have negative 100. Now, when I bring something down, notice there's no plus signs or minus signs. When I bring two numbers next to each other, that's a times. So negative 100 times, I have 4x. I have negative 100 minus 1. So my h prime of x would be, multiply these, negative 400 x to the negative 101. So remember, no calculator. We've got to be able to add, subtract, and multiply in our heads here. All right, so let me put a polynomial together here for you. Polynomial is just a term with many terms in it. And let's go through it. F, I'm going to derive. So the derivative of f is called f prime of x. And I'm going to derive each piece. Take the exponent, bring it down in front. So that becomes 4. X subtract 1 gets me 4x cubed. Plus, why don't you pause it and try the next 3 terms, see if you can figure it out. So I'm going to bring the 3 down. So I have 3x subtract 1, I get squared. Plus, bring the 2 down, 2x subtract 1, and I get 1. Plus, now you might be thinking, oh no, there's not an exponent. Well, of course there is. Everybody has an exponent of 1. So let's think about this. If I bring the 1 down and I subtract 1, I get x to the 0. Well, what is x to the 0? X to the 0 is just 1. So this becomes just a 1. 1 times 1 is 1. Now, wait a minute on this last term. There is no x. Well, then it's not the power rule. There is no x. It's not the power rule. Let's talk about this for a moment. So perhaps we should have talked about this earlier as well. I need the derivative of a constant. So let's get this in your notebook. Derivative of a constant. And again, a constant is just a number. All right, so remember, here's what you want to talk to yourself. The word derivative just means slope. So I'm really looking for the slope of a constant. Well, let me give you a constant to graph out. Y equals 5. If I graph y equals 5, and I ask you, what is the slope of that line? Hopefully you say it has a slope of 0. So I'm going to put m equals 0. If I graph y equals negative 2. So 1, 2. Here's y equals negative 2. What is the slope of that line? Well, again, it's a flat line, so it has a slope of 0. There's no incline. Its slope is 0. Excuse me. So the slope of any constant is always going to be 0. So let's get that notation in there. The derivative of, I'm going to call it c for constant, will always equal 0. So let's go ahead and box that in, get that highlighted in your notebook. The derivative of a constant is 0 because a constant is just a flat line and its slope will always be 0. So then I can definitely say I get a plus 0 here. So let's clean up our final answer. F prime of x equals 4x cubed plus 3x squared plus 2x plus 1. Now, I want to talk about just this x term again. X is linear, like y equals mx plus b. The number in front of x is just your slope when it's linear. So technically there's a 1 here, right? So the number in front should be my slope, which it does prove to be. I should just get a slope of 1 there. All right, number 8. So let's just go through each piece and take its derivative. So f of x becomes f prime of x. Okay, I'm going to take the exponent, bring it down. 7 times 3 is 21. X to the 6, so subtract 1. So remember, you're bringing it down, multiply numbers next to each other, then subtract 1. Minus, take the exponent, bring it down. 5 times 4 is 20. X to the subtract 1, I get 4. Minus, now you might be getting nervous because you see fractions. You're going to see a million fractions this year. We'll just get used to it. I'm going to bring the exponent down. So maybe write this one out for yourself. I'm going to bring 3 down, and you still have 1/3. X subtract 1, you get 2. And we'll multiply those in a minute. Plus, bring the exponent down, 2x to the first, minus, remember this is linear, so you can just say the slope is 3. Or off to the side, you can say if I have minus 3x, so I have that negative 3x to the first. If I bring the exponent down, that becomes negative 3x to the 0, and anybody to the 0 becomes 1. So you'll see that it's still negative 3. And then I have a constant, so its derivative is 0, and I'm not going to worry about it. So lastly, I'm going to clean it up and multiply those two terms together, of course. 3 times 1/3, remember you just put this over 1. So on top you get 3, on the bottom you get 3. 3 over 3 is 1. So I would say f prime of x equals 21x to the 6th minus 20x to the 4th. We just said that turns into a 1 minus 1x squared plus 2x minus 3. And that's it. That is the derivative. That is the slope of the function. All right, so I wrote this nice function here in green. Again, I want you to pause it, take the derivative, and I'll work my answer out, and then we can compare. So hopefully your answer does not agree. I just see I made a mistake. This derivative should just be minus 2, not 2x. So that's 24x cubed. That should just be minus 2. This became a constant, so it's a 0 slope. Minus 5, minus 6x to the negative third. Now I am going to clean this up a tad. So I have the 24x cubed. I can add negative 2 and negative 5. Those are like terms, so I have minus 7. Now, on the last one is the one that we did a lot in Algebra 2 with, okay? Negative exponents always go down to the denominator. Now, this negative 3 is not on the 6. It is only on the x. So my final rewrite here is going to be minus 6 over x cubed. Okay, I'm moving the negative exponent term to the denominator. All right, now some of you might be thinking this is way too easy. Maybe some are thinking it's okay, it's too hard, I don't know. But if you're thinking it's too easy, it does get a little more complicated. And you'll see in the next sentence here, I wrote rewrite first, okay? So I want to remind you of the power rule. The power rule has to be x to a number. Okay, so if I look at question 9 here, this does not look like x to a number, and that's why I'm saying rewrite first. You have to make it look like x to a number. So this is saying take the derivative of 1 over x. So I'm going to rewrite this function so it looks like x to a number. Well, I don't want to see a fraction with an x in it. I need to bring that up to the top. So to move things, remember you just make the exponents negative. So this is really asking me to derive x to the negative 1. Okay, so again, we did a lot of this in Algebra 2. Why is x to the negative 1 the same thing? Well, any negative exponent moves to the bottom, and there's a coefficient of 1 here, so that's 1 over x. So I need to derive this function, so I'm just going to apply that power rule. Take this first exponent, bring it down in front, and then subtract 1, negative 1 minus 1. So I would get negative 1 x to the negative 2, which is equivalent to negative 1 over x squared. Again, this squared is only on the x, so that is the only part that's going to the denominator. The negative 1 stays on top. Number 10, they give me f of x. They want to find f prime of x. All right, so let's rewrite first because this term does not look like x to a power. So I'm going to rewrite f of x, not calling it f prime yet because this is still f of x. This becomes x to the what power? Well, if this is a cubed root, so again, all of this is from Algebra 2. If this is a cubed root and this has an exponent of 1 here, we call this x to the 1/3. Roots go in the denominator. That's how we kept saying it over and over again. If you think of a flower, okay, or a tree or whatever you have, the roots that you have are always in the bottom. So the name of the root should always go to the bottom of the fraction. So this is x to the 1/3 minus 2 pi x to the 5th. All right, now we are ready to take the derivative. So now I can call this f prime of x. I'm going to take the exponent and bring it down. So that's 1/3 x. Now, it might be helpful in the beginning to write this before you're really good with your fractions. I want to subtract 1. Okay, but that's not easy to do maybe right off the bat in your head. What's another way to write 1? Well, when you want to subtract fractions, you need common denominators. So instead of calling this minus 1, I'm going to call it 3/3. Does that make sense to you? I want the denominators to be the same, and 1 is equivalent to 3/3. So I'm going to call this f prime of x equals 1/3 x to the 1/3 minus 3/3 minus, now all of this is a coefficient. They like to throw pi in there to mess with you, but pi is just a number. So these two are considered constants. So I'm still going to take this 5 and bring it down in front, times 2 pi x, I think I can subtract that in my head, minus 1 would get me a 4. And then I'm just going to clean this up. So I'll be right over here. I'm going to get f prime of x equals 1/3 x raised to the 1/3 minus 3/3. Well, 1 minus 3 is negative 2/3. Minus, multiply these together. That's 10 pi x to the 4th. And lastly, I'm going to work on my cleaning things up. Okay. Because there is a negative exponent, I know we're going to make a fraction. Okay, and this whole function is going to go to the denominator. Now, this negative 2/3 is only on the x. So, this is one term because they're all being multiplied. The 1 goes on top, the 3 on the bottom for the 1/3. This piece is going to the bottom because of the negative exponent, and I'm going to call it the cubed root of x squared. So again, the name of the root is the bottom, and this is the power on top. The high number is the power. Minus 10 pi x to the 4th. All right, let's try another one. Find dy dx. So again, another way to say take the derivative. So none of these terms here are rewritten as x to a number. So I need to rewrite each one. So the first one is y equals x to the, we know it's a fraction because it's a root. The name of the root goes on the bottom. So x to the 7/3 minus. Now remember, they don't put a number on all the roots because this one is implied. If this is called a square root, then you should assume that the power there is a 2. The root is a 2. And this is x to the 1st. So this is x to the 1/2. Plus, this has a 2 in front. This is x to the name of the root is a 5th root. So this is x to the 2/5. Now that I rewrote, I'm ready to take the derivative. So I'm going to go to each term. Y becomes dy dx, or you can call it y prime, but they mean the same thing. Okay, 7/3 comes down in front. X, and I'm going to take 7/3, and I'm going to subtract 1, which I'm really going to call 3/3. Minus, the exponent comes down in front, 1/2. X, and I'm going to say that's 1/2 minus 1, which I'm really going to call, I want the common denominators, 2/2. Plus, bring the exponent down, 2/5, leave the whatever's there. Remember, it's a times, 2x, and I'm going to say 2/5 minus 1, but in this case, I'm going to call it 5/5 because I want those denominators to be the same. And now we're just going to carefully clean these up. So I have dy dx equals 7/3 x to the 7/3 minus 3/3. I'm really just subtracting the tops. Gets me 4/3 minus 1/2 x. 1 minus 2 would be a negative 1/2 plus, now remember, I want to multiply. I'm going to make this a fraction. When you multiply fractions, you multiply the tops together and the bottoms together. So I'm going to call that 4/5 x, subtract my numerators, to the negative 3/5. Now, these are all multiple choice questions, so based off your answer, you might be done, but they're probably going to rewrite it in terms of roots and fractions. So let's clean this up even further. So the calculus is done. Now we're just cleaning it up. So dy dx equals, so no fraction because this is a positive exponent, so I'm going to call it 7/3. Remember, the denominator is the root, so this is the cubed root of x to the 4th. I have a minus sign. Now, this does turn to a fraction because it has a negative exponent. So I'm going to start with this fraction, 1/2. This is going to go to the denominator because it's a negative exponent, square root of x. Keep my plus sign. Negative exponent, so this piece, it's only on the x, will turn into the denominator. So 4 is in the numerator, 5 in the denominator, and this becomes the 5th root of x cubed. And that, my friends, is our final answer for the derivative. Okay, So here's a good time. I want you just to rewrite it. So pause it, rewrite it, and let's compare that step. And then we'll compare derivatives after that. So pause it and just rewrite it so it's x to a power. All right, how does that compare to yours? Okay, I had to move that x up, so it became x to the negative 1. This is really a square root, so my exponent should be 9/2. And then I didn't really have to touch the other two. If you're comfortable there, let's again pause it. Try the derivative. Don't worry about cleaning it up. Try just taking the derivative, and we'll compare that line next. All right, take a look at my derivative. I have dy dx, obviously. I brought this down, so that became negative 2 x to the negative second, because I subtracted 1 up here. Brought this down. So I kept my 4x, and then I did my 9/2 minus 2 over 2. Brought my negative 4 down times 3x. I'm doing negative 4 minus 1. Now, you notice I don't have anything at the end because pi is, remember, 3.14159265358, blah, 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 blah. It is a constant. So its derivative is 0. So let's go ahead and clean it up now. dy dx equals, and I'm going to, hope I don't go too fast for you. I'm going to kind of clean things up in a step. This negative 2 is only on the x, so it is going to turn into a fraction. So the negative 2 stays on top and x squared into the denominator. We're multiplying this, so I'm going to put this over 1. 9 times 4 is 36. Divided by 2 gets me an 18. If it's easier, you could do 2 goes into 4 twice. 9 times 2 is 18. X to the 9/2 minus 2/2 makes that a 7/2. 4 times 3, so that's going to be minus 12, x to the negative 5th. And like I said, I'll clean it up one more time to take care of any negative exponents because we really don't leave those there. Negative 2 over x squared, plus this is 18. This x to the 7/2, that 7/2 is only on the x, so it's the square root of x to the 7th. And this is going to be this x to the negative 5 is only on the x, so minus 12 over x to the 5th. And again, that should be our final answer for the derivative. All right, we've got 2 left to practice here. Again, it's all about the rewrite. Let's try to make everything into x to a power. So this is not the derivative. I'm just rewriting. I need this to be x to a power, so I have to bring that up top. So I'm going to call that 5x to the negative 2. All right, now, these fractions drive people crazy. Just bear with me. I think it's very simple. If you see a 5 on the denominator, then it's something a fifth. What number's in front of the x? Well, there's always a coefficient of 1. So this is just the number 1/5 times x squared. Try the next one. This is really just the number 2/9 and then x to the 5th. And then minus 4 pi to the 4th. Okay, don't be intimidated by these fractions. Just slow down and say, what number am I really staring at? Now we have an x to a power for every single one of these. So we are good to go. So why don't you pause it, try the derivative, and then we'll compare. So I'll just take the derivative, and then we'll clean it up in another round. So pause it and give it a try. All right, so my f became f prime. I brought my negative 2 down, so I did negative 10 in my head, x, and if I subtract, sometimes I'll put my minus 1 up there for myself, so I know that's a negative 3. I just brought my 2 down times my 1/5 x, subtracted 1, I got a 1. I have my 5, my 2/9, subtracted 1, I got a 4. And I really tried to mess with you on this one. Notice, is there even an x? No, that means it's a constant. This is really just 4 times 3.14 to the 4th power. It's all just a number. It's some ugly number. I don't care what it is. It's just a number. So its derivative is 0. And now I'm just going to clean this term up here maybe once or twice. This negative 3 is only on the x, so I'm going to say this is negative 10 over x cubed. 2 over 1 times 1/5, so I'm going to multiply the top, so that's 2 over 5, and that's an x. Again, I'm going to put this over 1, I'm going to multiply the tops, that's plus 10 over 9, x to the 4th. And there's really nothing else to clean up because I don't have any other negative exponents. All right, last one to tackle. Again, let's do the same thing. Let's just rewrite it first. So pause it, rewrite it, and let's compare that before you take the derivative. All right, so again, fifth root of x cubed, it's negative, it comes up to the top. This is a negative to bring it up, it's a 1/2. This is just the fraction 5/8, bring up that negative. This is just the fraction 2/11, bring up that cubed root. And we're ready to derive. So again, I would try to pause it, do the same thing. I'll take my derivative and we'll compare. All right, so I think I have my derivative that I'm comfortable with. Took this exponent, brought it down, so negative 3/5. And I have negative 3/5 minus 5/5, so that's going to be x to the negative 8/5. I brought down my negative 1/2. I'm going to make that a fraction, so this is going to be minus 5/2. X to the negative 1 minus 2 would be negative 3/2. Negative 1 times 5/8 is just going to be a negative 5/8. X to the negative 2, negative 1 minus 1. This negative negative is going to make a positive. On top, I get 2/33 on the bottom. And I'm going to get x, negative 1 minus 3 would be negative 4/3. And then my last step, of course, is just to clean this bear up. Negative exponents going to the bottom and putting anything into radicals that need be. So this has a negative exponent, so this x is going to the bottom. So I'm going to say that's negative 3 over 5, and this is the fifth root of x to the 8th. This is going to the bottom, so I have negative 5 over 2, and that is the square root of x cubed. Minus this is going to the bottom, 5 over 8 x squared. And then this is going to the bottom as well, plus 2 over 33 cubed root of x to the 4th. Well, that does it for round 1 of the power rule, and we'll get some more practice with the little tougher ones in the next lesson.